All right, so in the next one, we've got a little bit more of a normal example where you just have a car driving around. Um, yeah, maybe I should have put this one first because it doesn't have the extra step on the end, but at least it allows you to compare the two and see the difference. Um, this one, because it's asking for centripetal force, think about it. We learned how to find centripetal acceleration a second ago. So FC, centripetal force, mass is just mass. It doesn't change depending on other things. So it's just M. And then centripetal here. So, think where we had F equals MA before, it was F net. And, so the labels are a little bit different, but, math and your calculator all works the same way. Okay, so we have mass, that's good. And well, we don't have the centripetal acceleration, so that's less good. But we learned how to do that recently. So v squared over r, right? And so then we can take our information here. Again, it's all in standard units, meters and seconds and kilograms and irregular sorts of things. So we can plug in and see what this is going to do without having to worry about any conversions here. All right, so 1964, quite a bit slower than a fighter jet, but that probably makes sense, I would think. Radius, kind of a big radius. This is like car driving around like the football field or something. 189.67 meters. We've seen how the units worked before, where the meters on top get squared but then partially canceled. The seconds get squared, but they stay that way and they need to. And so if we evaluate this part, we're going to find an answer about 50 times smaller than what we had on question one. So the centripetal acceleration for this part, 2.0336 so on meters per second squared. That was a 6, believe it or not. I don't know if that's better or worse. Yeah, we'll just pretend it looks like a 6. Okay, but that's what we were missing a second ago. So now we can plug that back in and we can get rolling with it. So we don't know the centripetal force, but that's okay because we want to. So at least that's our goal. The mass is 1434.04. A lot of fours in that one. Then the special acceleration, we're looking at centripetal acceleration, we'll multiply in and again give us a special force, and everything's looking good. So I have a little less room here, so I'm not going to write as much of the number. Presumably this is already on your calculator screen, so you would just go in and multiply these together. You shouldn't necessarily need to type that in again. The kilograms and the meters per second squared should combine with each other and give that definition for newtons. And then multiplying these numbers together, we get 2,916.39.